the secret life of a star. From cosmic baby to supernova. Every twinkling point of light you see in the night sky has a fascinating story to tell. A journey that spans millions, even billions of years. But don't worry, we're not going to keep you here that long. Today, we're going to compress the entire life cycle of a star into just a few minutes. No magic tricks here, folks. Just pure mind-blowing physics. Let's start at the very beginning, shall we? Picture a vast, dark expanse of space, seemingly empty. But wait, there's something out there. It's a nebula, an enormous cloud of cosmic gas and dust floating silently in the void. This, my friends, is where the physics begins. Now, you might think that a cloud of gas and dust doesn't sound very exciting, but hold on to your telescopes, because things are about to get interesting. You see, gravity is always at work, even in the depths of space. It starts pulling these tiny particles together, slowly but surely. As more and more material clumps together, something incredible happens. It begins to heat up. Imagine squeezing a giant cosmic stress ball. The more you squeeze, the hotter it gets. That's basically what's happening inside this growing ball of gas and dust. As gravity continues to do its thing, the temperature keeps rising and rising and rising until boom, we've got ourselves a baby star, also known as a protostar. But our stellar story doesn't end there. Oh no, we're just getting warmed up. Literally, as our baby star continues to grow and heat up, it reaches a critical point. When the temperature at its core hits a mind-boggling millions of degrees, something truly spectacular occurs. The hydrogen atoms at the star's heart start to fuse together, creating helium in a process called nuclear fusion. This fusion reaction is like lighting the fuse on a cosmic firework. Suddenly, our star bursts into brilliant life, flooding its surroundings with incredible amounts of light and heat. Congratulations. Our star has officially entered its main sequence phase. It's all grown up now, shining proudly just like our very own sun is doing right this moment. For millions or even billions of years, our star will continue in this stable, mature phase. It's the stellar equivalent of a 9-to-5 job, fusing hydrogen into helium day in and day out. But just like us, stars don't stay young forever. Eventually, they start to run low on fuel. When a star begins to exhaust its hydrogen supply, it enters what we might call its midlife crisis. But instead of buying a sports car, it does something far more dramatic. It swells up into an enormous red giant. Imagine our sun expanding so much that it swallows up Mercury, Venus, and maybe even Earth. That's the kind of cosmic growth spurt we're talking about. Now, here's where things get really interesting. The fate of our aging star depends on how massive it was to begin with. Smaller stars, like our sun, will eventually shrink down into what we call a white dwarf. These are incredibly dense, Earth-sized remnants that slowly cool over billions of years. It's a quiet, peaceful end to a long and productive stellar life. But for the big stars out there, the cosmic heavyweights, things are about to get explosive. Literally, when a massive star reaches the end of its life, it goes out with a bang that puts all our 4th of July fireworks to shame. In its final moments, the star's core collapses under its own enormous gravity. This triggers a chain reaction that results in one of the most awe-inspiring events in the entire universe, a supernova explosion. In just a few seconds, the dying star releases more energy than our sun will produce in its entire lifetime. It's a cosmic light show that can outshine entire galaxies. But even in death, stars continue to play a crucial role in the cosmic story. The supernova explosion scatters the star's elements far and wide across space. These elements, things like carbon, oxygen, and even gold, become the building blocks for new stars, planets, and maybe even life itself. It's the ultimate recycling program, operating on a universal scale. And there you have it, folks, the life cycle of a star. It's from its humble beginnings as a cloud of cosmic dust to its spectacular finale as a supernova. We've witnessed birth, life, old age, and death, all played out on the grandest stage imaginable. But here's the most amazing part. Everything we've talked about today, from the gravitational collapse of nebulae to the nuclear fusion in a star's core, to the mind-bending physics of a supernova, it's all happening right now, somewhere out there in the vast expanse of our universe. The next time you look up at the night sky, remember that each of those twinkling points of light is telling its own unique story. Some are just beginning their journey, others are in their prime, and a few might be on the verge of their grand finale. Stars may seem distant and mysterious, but they're not so different from us. They're born, they live, they change, and eventually they die, returning their substance back to the cosmos from which they came. It's a cycle of cosmic creation and destruction that has been playing out for billions of years and will continue long after we're gone. So the next time someone tells you that you're made of star stuff, you can smile and nod knowing just how true that really is. Because in the end, we're all part of this grand cosmic story. A tale written not with ink, but with stardust. And that, my friends, is the secret life of a star. From cosmic baby to supernova. No magic tricks, no smoke and mirrors. Just the awe-inspiring, mind-boggling wonders of physics at work in our incredible universe. So keep looking up, keep wondering, keep exploring, because the greatest show in the universe is playing out right above our heads every single night.
Stay curious.